Hey kiddos, today we are going to be discussing radicals. So let's go ahead and get started. So just a few rules, or I should say guidelines that you need to make sure that you follow. Okay, radicals, so radical guidelines. Number one, the item under the radical sign is called the radicand. Okay, so if I have the square root of 5ab, 5ab is considered the radicand. Number two, items under a radical symbol may be multiplied or divided. So notice square root of AB is the same thing as saying square root of A times the square root of B. Or if you have the square root of A divided by B, you can also break that down and be the square root of A divided by the square root of B. Number three, the radicand cannot be negative. So the square root of -4 is not allowed. This results in an imaginary value, and that's not something that we're going to deal with in geometry. Number four, the radicand cannot contain any perfect square factors. So I'm not sure why originally I put square root of 12, so that's a mistake. So scratch that out and put square root of 16. Square root of 16 is not allowed because 4 is a perfect square factor of 16. Okay, so yeah, make sure you scratch out those 12s and put 16s in its place. All right, number 5, the radicand cannot be a fraction, okay? We actually don't want to have fractions inside of our radicands. We're going to have to try and break those down. So it's not allowed because the radicand is 5 over 4. You'd have to break that down into square root of 5 divided by square root of 4, and then you'd reduce. Number 6, the radical symbol can be, wait, sorry, let me reread that. No radical symbol can be in the denominator, okay? We cannot have 1 divided by square root of 2. It is not allowed because the denominator contains a radical. We would have to break that down and simplify it. All right, so let's get going. So be sure you know your perfect squares. That's definitely going to help you when we're dealing with radicals. So complete the list. So we're doing perfect squares here. So 4 is a perfect square, 9 is a perfect square. After that, you should get 16, then 25, then 36, then 49, 64, 81, 100, and then guess what? I'm going to let you figure out the next one. And then you get 144, 169, 196, and I'm going to let you figure out the last one in this puzzle. So, example 1, we're going to be creating a factor tree for the following. So we're going to basically break down all the factors of 42 into a tree. So you always want to start off with what two values or what two numbers can actually multiply into 42, or I should say divide into 42. So let's go with, you can always start easy if you're not sure. And usually the easiest thing to do always is just start with 2, for example. So if I wanted to do 2 times 21 is 42, perfectly fine. 2, the only way you can break down 2 any further is 2 times 1. So technically we do not have to rewrite that. So I'm going to leave 2 alone because it's the lowest it can get. But 21 we actually can break down into 3 times 7. So if I list all the factors for 42, we would have 2 times 3 times 7. Notice 3 can't be broken down any further, and 7 cannot either. All right, now let's look at the next example, 66. I'm going to go ahead, since 66 multiples of 3, let's do 3 times 22. 3 times 22 is 66. 3 can't be broken down, but I can break down 22 to 2 times 11. So the factors for 66 are 3 times 2 times 11. All right, so now let us... All right, so coincidentally, these are the exact same values as the previous examples I did. So we should actually already know that the factor tree here is 3, 2, and 7 for 42. Now, in this case, because it's a radical 42, so square root of 42 is the question, the actual answer itself is going to remain square root of 42. And the reason why that's going to happen is because we have nothing in common here in our factors. So because we have no commonalities, then we cannot actually simplify the square root of 42. And then coincidentally, the second example also is the exact same situation. We do not have any values in common left in our factors, so none of them are alike, so we cannot put them together to try and simplify this. So the square root of 66 would actually, in its reduced state, stay square root of 66. The only way you can actually take that any further is to give me a decimal answer. So I added 2 more examples that I expect you to write in that we're actually going to work out that hopefully have something in common. So let's look at 52. So let's start off with 2 multiples of 52. I'm going to go with 2 and 26, I believe. And let's see, we can break down 26 to 2 and 13. 2 can't be broken down any further, 2 can't be broken down any further, and 13 cannot be broken down any further. So those are our factors. I'm going to kind of scratch out these values because I don't want to interfere when we're trying to find common values. I can circle what we have in common. So I have a pair of 2's. So because I have a pair of 2's, my pairs go outside of a radical sign or outside the square root sign, and what is left over goes on the inside. So in this case, I only have one value, so that would go under the radical sign. So the simplified version of square root of 52 is actually 2 square root of 13. All right, let's look at another one, 48. And 2 values that multiply to 48. I'm going to go with 8 times 6. All right, 8 can be broken down to 4 times 2. 6 can be broken down to 2 times 3. I can't break down the 3 any further. Can't break down the 2 any further. Can't break down that 2 any further. But I can break down this 4 to 2 times 2. So I'm again going to kind of scratch out all the values that I did break down because I don't want to end up accidentally using them when I'm trying to find common stuff. So now we circle what we have in common in pairs. Okay, so I have a pair of 2's and I coincidentally have another pair of 2's and then only one other item left over. So anytime you have more than one pair, you multiply those pairs to get the value that would go outside of the radical sign. If I were to have more than one item that was not a pair, you would also multiply those values together, and that would go inside of your radical sign. So we're going to take the 2 pairs of 2's and we're going to multiply them. So 2 times 2 is a total of 4, square root of 3, since that's the only thing that we have left. So the simplified version of square root of 48 is 4 square root of 3. All right, let's look at a few more examples here. Remember, I'm going to actually rewrite example 5, square root of 128 over the square root of 5. Okay, this is just going to kind of help me out. And the reason why I'm doing that is because 128 divided by 5 is not a perfect value. You get 25.6, so I can't just reduce that straight off the bat. So we're going to have to actually do quite a bit of work here. So first thing we need to figure out is what is our factor tree for 128? Yay. You can always, like I said, start off with 2 if that makes your life easier. And then from there, kind of figure out where you can go. So 2 times 64 gives you 128. 64 I can actually break down to, if I'm not mistaken, 4 times 16. And then 16 can be broken down into 4 times 4. And actually, we can break down that 4 to 2 times 2. Technically, I can break down these 4s as well to 2 times 2. All right, so I'm going to scribble out all of these values because we broke them down. And now let's look for our pairs. So we have 1 pair of 2, 2 pairs of 2, 3 pairs of 2, and then we have a Lone Ranger. All right, so we're going to multiply our pairs. So 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. So we get 8, and we had a square root of 2 left over. And that'll be divided by the square root of 5. Now, if you remember one of our guidelines, we cannot have a radical in the denominator, so that means we have to multiply the top and the bottom by the square root of 5. So we would get 8. Now, remember, you can multiply square roots. So square root of 2 times the square root of 5 is the square root of 10. Over square root of 5 times the square root of 5 actually becomes square root of 25. And if you remember your perfect squares, okay, the square root of 25 is actually just 5. Now we look to see if we can actually reduce anything else. 8 divided by 5 does not reduce. And the square root of 10 would also not reduce. So the answer then is 8 square root of 10 divided by 5. All right, example 6. We have 8 over square root of 3. So remember that rule again. We cannot have a radical in the denominator. So all I have to do is multiply the denominator and the numerator by that exact same square root. So we get 8 square root of 3 over square root of 3 times square root of 3 is square root of 9. Square root of 9 is a perfect square, and we should get 3. Now you look to reduce. 8 divided by 3 doesn't reduce. So we end up with 8 square root of 3 divided by 3. All right, we can actually multiply this through 6 times 15 to get square root of 90 is what we're trying to simplify essentially. Okay, so our factor tree here, I'm going to use the same two numbers, not 6 and 15. Doesn't make any sense for me to try and think of anything else since that's automatically given to me. 6 breaks down to 2 times 3. 15 I can break down to 3 times 5. Do they have anything in common? Notice I can't break those down any further. So that's why I'm moving on to do they have anything in common? And I actually have a pair of 3s. And then we have 2 values that are left out. So the pair goes outside of our parentheses. 3 square root of. Now, this is the first time we come across having 2 values, okay, that are not a pair. So all you have to do is multiply them. 2 times 5 is 10. So the answer then, square root of 90 simplified, is actually 3 square root of 10. All right, example 8. Again, we have a fraction. Can't really have a fraction. So first, try and see if you can actually reduce that perfectly. 63 divided by 8 does not reduce perfectly. So then we are going to have to break this down. So we have square root of 63 divided by the square root of 8. Now, if you want to go ahead and multiply both sides by square root of 8 first from the get-go, you can. Or I usually like to try and break down my bigger square roots first before, just to see if it'll make my life a little bit easier. So let's just go ahead and do that. So we have 63. Looking for 2 values that would give us 63, and that would be 3 times 21. 21 could be broken down into 3 times 7. If I'm not mistaken, that's as far as we're going to get. So 3, 3, and 7. We have a pair of 3s, and then left over is a 7. So you end up with 3 square root of 7 divided by square root of 8. As before, we cannot have the radical in the denominator, so I have to multiply the denominator and the numerator by that exact same square root. So we get 3 square root of 7 times square root of 8 divided by square root of 8 times square root of 8. So 3 square root of 7 times 8 gives us 56 over square root of 8 times square root of 8 is going to be square root of 64. That is a perfect square. We end up with 8. Now, normally we may be done, but in this case, we're not because we have a square root of 56. Now, if I'm not mistaken, I think we can break down 56. So I already know 56 is 7 times 8. Might as well use those values. 8 does break down into 4 times 2, and 4 breaks down into 2 times 2. So I know that we have for sure a pair of 2's, and then we have 2 values left over. Those were broken. Sorry, I didn't mean to scratch that part. There we go. And scratch that one out. So we would end up with, now be careful because we already have something on the outside, so you can't forget about it. So we're going to take what's on the outside already and multiply it with the pair that we just discovered. So 3 times 2, 6, square root of, what do we have left over? The 7 and the 2. So 7 times 2 is 14. And then we are going to divide that by 8 because that's what we have here in the original problem. Now we look to reduce. Can you reduce 6 divided by 8? I think you can. 2 goes into 6 3 times. Square root of 14 stays, divided by. And 2 goes into 8 4 times. So that would be the simplified version of square root of 63 over 8. All right, so here's a few problems for you to do on your own. The first one is square root of 3 times square root of 3. Hopefully you caught on to our secret here. Number 2, you have the square root of 15 divided by 21. If you can reduce it, and then continue to work it out. And then the last one here, we have 3 divided by square root of 48. Remember, you cannot have that square root of 48 in the bottom, so you're going to have to multiply top and bottom by that square root of 48 to get rid of it in the denominator. So, be sure to write any questions that you may have throughout this. I know it's a little bit intense, but I know you guys can handle it. Have a great day.